Hi everyone, good morning. Can you able to hear me? And is my screen visible to you all? Yes. Okay, fine. Good morning everyone. Good morning Aditya. Good morning Jia. Okay, fine. So have you done the homework that I have given you yesterday? Everyone have done it? Yes. Good morning Rohit. Okay, fine. So in today's class, like we are going to discuss the questions on D and F block elements. Okay. Have you gone through the chapter once? I've told you yesterday itself, right? Go through the chapter once, like go through the short notes what you have. So it will be like, yes, very good. Okay. So if you revise, then your brain will get refreshed with that chapter, so you can solve the questions quickly. Fine. Okay, so we'll start the session. So moving to the first question. Okay, so it is a PYQ. So the question is the reaction of Hc and O to F2 gives a xenon compound P. The number of moles of HF produced by the complete hydrolysis of 1 mole of P is. Okay, you have to find out the number of moles of HF which is produced by the complete hydrolysis of 1 mole of okay. So like what is the answer? Can you guess the answer? Like you have to react Hc with O2F2. You have to react Hc xenon with O2F2. You will be getting a compound P. Okay, so the number of moles of H complete hydrolysis of 1 mole of P is the question. Okay, so now we'll solve it. Like xenon plus O2F2, you'll get HCF4. Okay, xenon plus O2 gives HCF4 plus balance the equation because you have to like do it by considering number of moles. Okay, if you want to like calculate the amount, then you have. So what will be the equation? Hc plus 2O2F2 gives HCF4 plus 2O2. 2O2. Okay. Now, what is the xenon compound P? P is HCF4. Okay. So now, when you do the complete hydrolysis of HCFO, what would be the number of moles of HF produced is the question. Okay. So you're going to do the hydrolysis. Hydrolysis of HCF4. Okay. So I'm adding water. So if you do the hydrolysis, so what are the compounds you're going will be getting HCO3, okay, then on HCF4, on hydrolysis, it takes up like oxygen and produces HCO3. It gives out a xenon, it gives out O2, sorry, it gives out O2 and it gives out HF. Okay, so now balance the equation so such that you'll get the number of moles of HF produced by the complete hydrolysis of 1 mole of P. Okay, 1 mole of HCF4. So HCF4 is your P. Okay, now balance the equation. So if you balance the equation, you have like HCF4, but you have like 2 xenon over here. Okay, so you have to balance it. So I'll be getting like 6 FeF4 plus 12 H2O will give you like you have 12 times of oxygen. You have like 3 plus 2, 5 times. Okay. So 2 times if I put, I'll be getting 6. So if I put 3 times, it is going to be 6. So it is going to be like 12. Okay. And remaining like 6 xenon. Here I have written 2 xenon. So 4 xenon over here. So what would be the number of molecules of HF? 12 into 2 is 24 HF. 6 into 4 is 24 HF. So how will you solve? Like they have asked for the 1 mole. Okay, they have asked for 1 mole. So we got HCF4 and HF. Okay, balance the equation. What is the stoichiometric coefficient of HCF4 is 6. And what is the stoichiometric coefficient of HF is 24. So for 1 mole, what HF produced? What will be the number of HF produced? Yes, it is 4 moles. So the answer is going to be like, okay, got it everyone? Yes, fine. Moving to the next question. The thermal decomposition of AgNO3 produces two paramagnetic gases. Okay, when you do the decomposition of AgNO3 silver nitrate, you will be getting like two paramagnetic gases. The total number of electrons present in the anti-bonding molecular orbital of the gas that has the highest number of unpaired electrons. Okay, so you're going to do the thermal decomposition. You'll be getting like two paramagnetic gases. So which is like D and F block. Okay, the total number of electrons present in the anti-bonding molecular orbital. So it is from chemical bond. So two concepts merged together in a single question. Okay, so what you're going to do is you're going to decompose AgNO3. So when you decompose like AgNO3, what are the gases you'll be getting? Thermal decomposition. So what are the gases you'll be getting when you do the thermal decomposition? Okay, so one will be like oxygen. Okay, one will be like you have NO. Okay, so nitrogen and oxygen, you have like NO2 gas will move out and you're getting like Ag. Okay, two gas. So 2AgNO3 will give you O2 plus 2NO. So this is the balancing equation. Okay. So now what are the gases you got when you do the thermal decomposition? I have got like oxygen and NO2 gas. What are the two gases? Is oxygen and NO2 gas. Okay. Now, what about the oxygen and NO2? What about the oxygen and NO2? Okay, so the total number of electrons present in anti-bonding molecular orbital of the gas that has the highest number of unpaired electron. Okay, now are they both are paramagnetic or diamagnetic? Both are paramagnetic or diamagnetic? Okay, so tell me like O2 is paramagnetic or diamagnetic?
Diamagnetic.
Right? Do you remember? Yes, it is. It is paramagnetic. But if the number of electron is off, or if the number of electron is going to be 10 to 16, it is going to be paramagnetic. Yesterday we have discussed. Yes. And all the other except 10, 16, even number of electrons will be. Okay. So here the number of electrons is like you have 16, so therefore it is going to be like paramagnetic. It is going to be like paramagnetic. Okay, so is my screen visible now? Is my screen visible? Am I audible? Fine. Okay. Okay, sir. So NO2 is also going to be like paramagnetic. It is also going to be like paramagnetic. Now what you have to do is, which has the higher unpaired electron. Okay, so both has unpaired electron. Like in the question itself, they have told like it has the unpaired electron. Yes, so both has unpaired electron. So what is the number of unpaired electron in O2? In O2, what is the number of unpaired electron? Is going to be like 2, and the number of unpaired electron in NO2 is going to be like 1. Okay, so which has the maximum number of unpaired electron? O2 has the maximum number of unpaired electron. Now we have to do the total number of electrons present in the antibonding molecular orbital. Okay, so what it wants for O2 in antibonding molecular orbital? Now can you write the configuration, MOT configuration for O2? MOT configuration for O2 is going to be like sigma 1s2, char 1s2, sigma 2s2, sigma char 2s2. And then, okay, whether pi bond will come or sigma bond, sorry, pi orbital will come or sigma orbital will come. So here the number of electron is 16, which is greater than 14. So is sp mixing possible? Is sp mixing possible or not? When the number of electron is greater than 14, do sp mixing possible? No. You will be writing over here is like the pi orbital. Okay, pi to px, pi to py. So each contains like Q2 electrons. Then comes the sigma to pz, and then will be pi to px star 1, pi to py star 1. Okay, so totally we have it like 16, 2, 4, 6, 8, 10, 12, 14, 15, 16. Okay, now what you have to do is count the total number of antibonding molecular orbital electrons. Yes. So now can you count? We have like 2, 4, 5, and 6. Okay, you have like 2, 4, 5, and 6. We have to like calculate the total number of electrons present in the antibonding orbital. Okay, so you have to count from the diameter. Okay, not total of p orbital alone. They have asked for the total numbers. You have to count from sigma 1 star, sigma 2 star, and then pi to px star, pi to py star. Okay, so how many electrons are there? Like 6 electrons. So the answer is going to be like 6. 6 is your answer. Got this question, everyone? Any doubt? Shall I move with the next question? Okay. So move the next question is, so an acidified solution of potassium chromate was layered with an equal volume of amyl alcohol was taken after the addition of 1 ml of 3% H2O2. A blue alcohol layer was obtained. The blue color is due to formation of chromium 6 compound. What is the number of oxygen atom bonded to chromium through only single bond in a molecule of X? Is the question. Okay. So read the question. Like you have potassium chromate. Okay, acidified solution of potassium chromate. It was layered with an equal volume of amyl alcohol, and you're shaking it. After shaking, adding like 3% H2O2, a blue alcohol layer was obtained. And this blue alcohol layer, why it is formed? Due to formation of a chromium 6 compound. Means compound has the chromium in +6 oxidation state. Now the question is, what is the number of oxygen atoms bonded to chromium through only single bond in a molecule of X? Is the question. So first what we have to do? Like we have to write the equation. So I have like potassium chromate. Okay. So I'll write this one as like CrO4 2 minus. Okay. Potassium chromate. It was layered with it is an acidified solution. So heating with like H plus. Okay. So it is treated with amyl alcohol and H2O. So I'm treating it with like H2O. Okay. So what happens over here is you'll be getting a chromium compound with oxidation number of 6. Okay. So when you do like H2O2, it can act both as an oxidizing agent and reducing agent. Oxidizing agent and reducing agent. Okay. So here you have like H plus. Here you have like H plus. So what does this H2O2 will do? It will oxidize it to H2O. It will get converted to H2O. So what is remaining? You have like chromium CrO5. We'll be getting the compound as CrO5. Okay. So here, what is the oxidation state of chromium? We have to calculate. We have to calculate. CrO5, you have to draw the structure, Lewis structure of CrO5. So I have like chromium. It is bonded with like 5 oxygens. Oxygen, 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 oxygen. Okay. So now what is the maximum valency of chromium? What is the maximum valency of chromium?
+6.
What is the maximum valency of chromium? Yes, very good. Plus. Yes. So chromium is orgon 3d5 4s1. Okay, so therefore it is going to be like +6. So it can form like 6. Okay, so I'm making and I'm making like 4 single bonds. So therefore chromium valency will get satisfied. Okay, now what you can do is like oxygen can form like 2 bonds. So I'm making a peroxide over here. So I have used the hydrogen peroxide. So therefore chromium also forms the peroxide. Now, what is the oxidation state of chromium? What is the oxidation state of chromium?
+6.
Yes, it is +6. So -2, -1, -1, -1, -1. So it is going to be like +6. So we got the chromium 6 compound. Now the question is, what is the number of oxygen atoms bond to chromium through only a single bond in a molecule? So how many single bonds with chromium and
4
oxygen?
atoms.
So 1, 2, 3, and like 4 single bond. The answer is going to be like, got this question, everyone? Yes. Next question. Among the species given below, the total number of diamagnetic species is. Okay, you have to calculate the total number of diamagnetic species. So hydrogen atom is there, NO2, O2 minus peroxide, dimeric sulfur in base, NH4, NH4 twice FeCl4, NH4 twice NaCl4, K2MnO4 and K2CrO4. You have to calculate the total number of diamagnetic species. Okay, so like we have discussed in chemical bonding, how to do like now too we have discussed like by using calculating the total number of electrons we can do it. Okay, so I'll just wait for like 2 minutes. Can you give the answer? Try to give the answer. Yes, everyone. Just try to solve this question. Okay, fine. So moving with hydrogen atom. So how many electron does hydrogen have? Only one electron. Okay. So therefore it is going to be like paramagnetic. So it is paramagnetic. Now moving to like NO2. NO2. Draw the Lewis structure of NO2. So it will be N double bond O. Okay, so two electrons. This one, it forms a coordinate bond. So you will have like one odd electron. So it itself shows that it is paramagnetic in nature. Now, can you tell me like O2 minus is paramagnetic or diamagnetic? O2 minus is paramagnetic or diamagnetic? O2 minus. So you have like 16, you have like 17 electrons, so therefore it is going to be paramagnetic. And dimeric sulfur in vapor phase. Dimeric sulfur in vapor phase is like S2. Okay, so S2. So what would be the total number of electrons in S2?
52.
Like you can tell like O2, right? O2. It comes under the same group, okay? And we know that like for O2, it is 16. Okay, so therefore, here it is going to be like paramagnetic. Okay, all the odd electrons, 10 and 16 electrons are going to be paramagnetic. So S2 is also going to be like paramagnetic. And then comes like Mn3O4, Mn3, okay, O4. So 1, 2, 3, 4. Join all the manganese and oxygen. Okay, so I have like Mn3O4. Yes. Now, what is the oxidation state of first Mn? It is going to be like -1, so +2. And it is going to be like +4 and +2. So you have like manganese in +4 and +2 oxidation state. So now the configuration of manganese is argon 4s2
3d7 4s2.
3d. Okay. So now how many you are going to write like 2 electrons you are going to remove. So it is going to be like 3d5. Okay. So if it is 3d5, whether it is paramagnetic or diamagnetic?
Paramagnetic.
Paramagnetic. So this manganese is paramagnetic. What about like Mn4 plus? You're going to remove like 4 electrons, so 2 electrons from
3d3.
S and 2 electrons from D. So 3d3, it is also going to be like paramagnetic. So it is purely paramagnetic. Yes. Now moving to like NH4 twice FeCl4. NH4 twice FeCl4. Now what is the oxidation state of Fe in NH4 twice FeCl4? What is the oxidation state of Fe? So, yes, it is +2. Okay. So, +2 oxidation state. So, what will be the configuration for Fe +2? It will be argon 3d6. Argon 3d6. Okay. So, argon 3d6. And here, whether the pairing takes place, pairing take place at FeCl4. No, right? So how many unpaired electrons it will be having? Like 4 unpaired electrons. So this is also going to be like paramagnetic. And moving to like NH4 twice NaCl4. Okay. Here too it will be like nickel 2 plus. So it will be argon 3d8. So it has like 2 unpaired electrons. So here the number of unpaired electrons is 4. Here the number of unpaired electrons is 2. So both are going to be like paramagnetic. So this is also paramagnetic. Now moving to like K2MnO4 minus K2MnO4. So can I write it as like MnO4 to minus MnO4 to minus. So now draw the Lewis structure. Mn have like 4 oxygen. So here you'll be like double bond, 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 minus, minus. Now what is the oxidation state of Mn? It will be having like 4, 5, 6. So plus 6 oxidation state. If it is like plus 6 oxidation state, then so you have like 1 unpaired electron. Yes, number of unpaired electrons is going to be 1. So therefore it is going to be like paramagnetic. So this is also paramagnetic. And what about like K2CrO4? You can write CrO4 2 minus. Okay, so chromium double bondo, bondo minus minus. Now, what is the oxidation state of chromium in K2CrO4?
Plus 6.
Okay, minus 2, minus 2,
And
minus 2.
diagonal.
Okay, now whether it's like paramagnetic or diamagnetic. It is diamagnetic. So among following, only one is diamagnetic. So the answer is going to be like, okay. Clear with this question, everyone?
Yes, ma'am.
Now moving to the next question. How many hydrogen bonded water molecules are associated with CuSO4.5H2O? So they have asked for the number of hydrogen bonded water molecules. Now tell me, what is hydrogen bond? What is hydrogen bond? It is the interaction between hydrogen and more electronegative atom like fluorine, oxygen, nitrogen, sulfur, etc. Okay. So how many hydrogen bonded water molecules are associated with CuSO4.5H2O? Okay. So first I will draw the structure, hence you can get the answer easily. Okay. So now what is the oxidation state of copper in CuSO4? What is the oxidation state of copper in CuSO4?
Plus 2.
Yes, it is plus 2. 2 plus. Okay. So now it is like bonded with 5 molecules of water. It is bonded with 5 molecules of water. So I'm making like hydrogen, second water molecule, third water molecule, and fourth water molecule. Okay. And you have like sulfate, SO4 to minus. So SO4 to minus. SO4 to minus. Okay. Now, like there will be one water molecule in the middle. I'll just present color. So O, hydrogen, hydrogen. Okay. So now can you tell me like how many water molecule can form the hydrogen? Hydrogen can form hydrogen bond with oxygen, and this hydrogen can form hydrogen bond with oxygen. So what is the number of water molecule involved in the hydrogen bonding? Is 1. Okay. So only one water molecule involves in hydrogen bonding. So the oxygen of sulfur is hydrogen bonded with one water molecule, both the oxygens of sulfur. And the copper is associated with water molecule, right? The water molecule is getting again associated with the same water molecule in which the hydrogen bond has been made. So therefore, totally only one water molecule is involved in hydrogen bonding. So the answer is going to be like, got this question? Any doubts? Fine. Going to the next question. The number of equivalent CR bond dichromate Cr07 minus ion. We have to draw the structure first and find out the number of equivalent CRO bond. I have sent like yesterday's PDF, I have sent today's PDF also, I will send it. Okay. So the number of equivalent so draw the structure of Cr272 minus and find out like how many number of equivalent Cr bond O bond is present. Okay, I'll wait for like 2 minutes. Can you just solve this question? The number of equivalent Cr bond O bond present in dichromate Cr207 2 minus ions. Just draw the structure, you'll get the answer. Yes. Do anyone got the answer? Okay. So we'll draw the structure for Cr2. Okay. I'll tell you on that. Fine. So Cr2O7 2 minus, we have like 2 chromium and 7 oxygen. So 3 oxygen and 3 oxygen, 1 oxygen in the middle. Now we know that the maximum valency of chromium is 6. So it can form like 6 bonds. So I'm making like single bond shell. So 4 bonds done. So I can make like 2 more bonds. So 2 more pi bonds I'm making. Okay. The similar thing I'm writing in the other side. Okay. So now what is meant by like equivalent CRO bond? It means that the CRO bond length is going to be similar. It is going to be similar. So here you can see like you have a double bond. Okay. That should be like negative charge. Yes. You have a double bond. Here you have a double bond, double bond, double bond. And rest are the single bonds. And we know that like bond length of single bond and double bond is different. Yes. So which bond will be like longer when you compare single bond, double bond, and triple bond? Which bond will be like longer?
Single bond.
Single bond will be like long. Yes. So can I say that there will be like 2 different bond lengths? One is for single bond, the other one is for double bond. Okay. One is for single bond and the other one is for double bond. I can see. Now, we have started, like, I'll take the example of benzene. It also has single bond and double bond. Does benzene has like 2 different bond lengths between carbon and carbon? Do benzene has 2 different bond lengths between carbon and carbon? No. Why? Why? Due to resonance. Very good. Okay. So we know that like when I take the orbital, pi orbital, pi overlapping, we know that like these 2 orbitals can also overlap. These 2 orbitals can also overlap. Yes. So now what happens over here is like you can see that there is delocalization of pi electrons. So when does the delocalization happens? When does the delocalization happens? That is like when there is conjugation. When there is conjugation. So now what are the types of conjugation? What are the types of conjugation? Like pi sigma bond can be there, and after sigma bond there should be a presence of vacant orbital, or there should be presence of a radical, or there should be presence of lone pair, or there should be presence of negative charge with the lone pair. So these are the four types of conjugation. These are the four types of conjugation. Yes. So now when I look over here, I have a pi bond. Okay. So now you may think like you have the number of equivalent CR single bond O bond in dichromate is going to be like is the question. Okay. So you may think like you have like four double bond and you have like four single bonds and you'll be writing the answer as four. Okay, but that is going to be wrong because you here there is like conjugation. You can see you have a pi bond, you have a sigma bond, and next is the atom carries a negative charge. So will it undergo resonance now? Will it undergo resonance? Will this one undergo resonance? So what happens now? This one will get inside, that is the negative charge can get in, and the pi bond can move out to give like O minus double bond O. Yes, so resonance can happen. Now, moving to the next thing over here. You have a pi bond, you have a sigma bond, you have a negative charge. So here too the resonance can happen. So you'll get like, I'll write the structure down over here. So double bond O, okay, so you have like O minus double bond O. Now here too resonance can happen. So this one will move out to form a double bond O minus. So can I say like I can write the hybrid as oxygen, 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 and here there is a hybrid. Okay, can I say that there is like resonance hybrid? Yes. So now, what are the two different bonds? Same thing happens over here too. Okay. So you have resonance. So now, can I say the equivalent CR bond O is 3 over here and 3 over here? Can it take place over the oxygen atom? Can it take place like does the resonance happens in oxygen which is present in the middle? Okay, there is no. So now what is the number of CR bond O present in the dichromate ion is like 3 and 3. So the answer is going to be like 6. Very good, Rohit. The answer is like 6. Got it, everyone? Ankit, got it now?
Yes, ma'am.
Okay, fine. Now, to the next. Okay, so now keep the homework. Okay, find out the number of equivalent CR bond O. CrO4 2 minus is the question. Okay, same question is for CrO4 2 minus. Okay, just draw the structure and find out the number of equivalent CR bond. Okay. Now moving to the next question. How many ions are formed on dissolving one molecule of more salt in water? Okay. So when you dissolve like one molecule of more salt, what is the number of ions produced? What is the number of ions produced? Okay, so first, like what is more salt? Yes, it is 5. Very good. Yes. Yes, Rohit, you are right. So FeSO4 dot NH4 twice SO4 dot 6H2. Ferrous ammonium sulfate. Yes. So when you dissolve in water, Fe2 plus, and you have like SO4 2 minus, and you'll be getting like NH4 plus. Now just balance the equation. So you have like SO4 2 times of SO4 you'll have it. So how many NH4 plus? You'll have like same 2 times 2 NH4 plus. So the total number of ion is going to be like 5. So whether this more salt is the double salt or a complex. Whether this more salt is a double salt or a coordination complex.
Double salt.
Whether this more salt Yes, it is a double salt. It is a double salt. Okay. So, but when a complex is present, yes, you can't write the ions like this. It won't get ionized in water completely. Okay, you'll get like the coordination entity, and if there is like some presence of counter ion, that counter ion will come out separately. Okay, so that is the difference between the double salt and coordination complex. Yes. Okay, so the next question is, the green color produced in the borax B test of a chromium 3 salt is due to the formation of Cr2O3 or Crb or CrBO2 or Cr2B4O7. Borax B test. So why this test is used? Like borax B test, why it is used or where it is used? It is used to find out it is performed for the colored salt. Yes, it is performed for the colored salt. Now, what is the general reaction of this borax B test? We'll be taking borax Ne2B4O7.10H2O. When you heat this one, 10 molecules of water will get evaporated. So you'll be getting Ne2B4O7 plus 10H. Yes. So now when you heat this Na2B4O7, when you heat, what happens is boric anhydride will be formed like B2O3 and NaBO2 will be formed. Okay, sodium metaboric. We'll be getting sodium metaboric and boric acid. Okay, so now you're treating chromium 3 plus first. So Cr3 plus, when it is treated, it's B2O3 to form Cr. Okay, so here the oxidation state is 3 plus. Okay, the oxidation state is 3 plus. So how much amount of BO2 it will take? It will take 3 plus. Okay, so 2 times. So what is your answer? The green color is produced due to like CrBO2 thrice is the answer. Okay, got this question?
Yes, ma'am.
Okay, moving to the next question. Which of the following combination will produce H2 gas? Which of the following combination will produce H2 gas? Iron, metal, like concentrated HNO3. What does concentrated HNO3 will do? It will like make a layer of yes. So when you react iron with concentrated HNO3, the product will be iron nitrate,
Diammonium salt.
iron nitrate, yes, NO2 and water. Water. Now, when you react like copper with nitric acid, same, you'll be getting NO2 and H2. Okay, we know that like the metals will be passive with constant nitric acid. Now, when you react with zinc with NaOH, what you'll be getting? Zincate. Sodium zincate plus hydrogen gas will get liberated, and gold with NaCN in presence of air. You'll be getting the complex, right? Gold complex. So NaAuCN twice plus NaOH. Right. Therefore, this H is in presence of, it is an aqueous solution in presence of air. Okay. So the only combination which will produce hydrogen gas is like metal. And next question. Yes, which of the following arrangement represent the correct order of the property stated against it? So you have like vanadium 2 plus, chromium 2 plus, manganese 2 plus, iron 2 plus, which shows the paramagnetic indicator. Nickel 2 plus, cobalt 2 plus, iron 2 plus, manganese 2 plus, ionic size, cobalt 3 plus, Fe3 plus, chromium 3 plus, scandium 3 plus, stability in aqueous solution, scandium, titanium, chromium, manganese, number of oxidation states. So which of the following arrangement does not represent the correct order? And I'll check whether it is a single answer type or MCQ type. Yes, it is a single answer type. Only one option is right. Only one option is right. Which of the following arrangement does not represent the correct or against it? Okay, paramagnetic behavior. So tell me, like, medium. Okay, so the option is B. Fine, we'll see. Vanadium is 3D3. Yes, 3D3 for S2. So remaining like 2 electrons. So that's going to be like 3. For chromium, it is 3D5 plus 1. Removing 2 electrons, 4. For manganese, it is like 3D5 for S2. So removing 2 electrons, 5. Fe2 plus is going to be like 6. Is going to be like 6. Okay. Fe2 plus number of unpaired electrons. Number of unpaired electrons is going to be like 1, 2, 3, 4, 5. Number of electrons is going to be 4. Okay, so here the order is wrong. So since it is a single order type question, so option A is going to be the right answer. Okay. So when you move to the like oxidation state, for the same oxidation state, you can see the oxidation state is same. Okay, oxidation state, what happens to ionic size as the atomic number increases, the ionic size will decrease. Okay, it will be iron, cobalt, nickel, 25, 26, 27, 28. So as the atomic number increases, the size has been decreased. Okay, so this is the correct order. And the stability in aqueous solution. So the stability of the compound in aqueous solution, it depends on the electrode potential, standard electrode potential. Okay, so for cobalt, iron, chromium, and scandium. Okay, so for chromium, the order it is going to be like the scandium 3 plus is going to be like highly unstable because it will not show the +2 oxidation state. So it is going to be like highly, it is going to be like highly stable. Then comes like chromium 3 plus. So when you compare like chromium 3 plus to chromium 2 plus, the potential is minus 0.41, it is 0.77 and 1.97. So the order is like correct order. Scandium, titanium, chromium, and manganese, the number of oxidation. Scandium has like the number of oxidation state they have. So when you see over here itself, you'll get like manganese, the number of oxidation state is going to be like
Plus
+2
7.
to +7. Okay. Yes. So you'll be having like 5. 1, 2, 3, 4, 5, 6. Sorry. +2, +3, +4, +5, +6, +7. Okay. And for chromium, what is the number of oxidation states like from 1 to plus? So it is going to be like same. So this order is also right. So the incorrect option is like option A. Yes. So the next question, which of the following is not formed when H2S reacts with acidic K2Cr2O7? So write the equation. You have to write the equation for the reaction potassium dichromate and H2S and find out like when you write, you'll get the answer. Okay, which of the following is not formed when H2S reacts with acidic potassium dichromate? It is an acidic condition. So what would be the answer? Yes, it is going to be option. Yes, I have got like one more option as option B. Okay, so I'll write the equation. So K2 Cr2O7 reacts with H2S in presence of acidic condition H plus. Okay, so what will be H2? Like atom can take up, I'll write the thing as H2SO2. H2SO2. Okay, So potassium can take up sulfate to form K2SO4. And chromium can also take sulfate to form. You know the oxidation state of sulfate is SO4 to minus. Yes, SO4 to minus. So what is the oxidation state of chromium in acidic state is Cr3 plus. Cr3 plus, yes. So when you combine like these two, you'll be getting just cross multiply it. So Cr SO4 2 minus, so therefore Cr2 SO4, chromium's oxidation state is +3, so bring it here. So just do the cross multiplication. Cr2 SO4 thrice, so option D is formed, option A is formed. And we know that H2S is a good reducing agent, okay? So what it will do, it will get oxidized. So sulfur in -1 oxidation state is going to be to the 0 oxidation state. So sulfur will be small, okay? Plus water. So this is the equation. So this one will not be formed. So option is the right answer, okay? By getting out the oxidation state itself, you can pick the answer, right? So sulfur oxidation state. But if it is combined like only with one chromium and there is no charge at all, so the compound is not going to be like neutral. So option A is the this question. Question. And excess of N2O3 reacts to USO4 to of Na2S2O3. Na2S2O3 reacts with aqueous copper sulfate to get. Okay. So what would be the answer? What is the answer? So that's right equation between Na2S2O3 and thiosulfide and copper sulfate. What would be the answer? X is up. So first I'm taking like CuSO4 reacting Guys, can you able to hear me now?
Ma'am, your
Yes.
screen is not visible.
Okay, I'll share this. Okay, is it now? Is my screen
Now
visible
visible.
now?
Yes, ma'am, visible.
Not visible. Okay, fine. Okay, so I'll just repeat this equation. So excess of Na2H2O3 it reacts with CuSO together. Okay, so I have written like CuSO4 reacts with Na2H2O3. So now what happens is copper will take this H2O3 and Na2H4 will take it out. So again, like you're treating it with excess of Na2H2O3. You're taking the product and I'm reacting it with Na2H2O3. So you'll be getting Na2H2O3. So C2H2O3 plus H4O6. Okay, so this one will get with two kinds of H. Okay, I have some network issue over here. That is why fine. Okay. So clear this thing? Yes. So now what happens over here is like this one, it forms a complex of Na4CU6H2O35. So the option is going to be like the right option. Okay. So when you use like excess of Na2H2O3, then you'll be getting the complex. Guys, can you able to hear me? Yes.
No, ma'am.
And is my visible to you? See, the internet connection is getting stable. That is what the issue. Okay, voice is breaking. Is it okay now? Is my voice
Yes,
clear
ma'am.
now?
Now, okay.
Okay, fine, fine, fine. Screen is visible?
Yes, ma'am. Screen visible or voice is clear?
Okay, fine. Thank you. Okay, so moving to the next question. Okay, clear with this question, everyone?
Yes, ma'am. Sure.
Okay, so moving to the next question. So the following lantanoid ion is diamagnetic in nature. Okay, you have like they have given you the atomic number 2 and for atoms are given. So you have to find out like which diamagnetic in nature. Okay, so you can do it like writing the configuration. You can find out like which is diamagnetic in nature. So what would be your answer?
D.
Okay, so it is option D or D. I got like one answer. Yes. What about others? Yes. So we'll try the configuration for samarium. It is like 62. So it would be like xenon 4f6 6h2. Okay, so how many unpaired electrons? It has unpaired electrons, so therefore it is going to be paramagnetic. Paramagnetic. And like ytterbium, it is xenon 4f14 6s2. Okay, it doesn't have any unpaired electrons, so it is going to be like diamagnetic. For europium, it is xenon 4f14, sorry, 4f7 6s. Okay, so it has like 7 unpaired electrons, paramagnetic. And for cerium, what is the configuration? Xenon, you have like electron in f orbital as well as the d orbital. Yes, so T1 6s. So you have like unpaired electron. So that option C is the right answer. Yes. Multiple correct answer. Moving to the first question. Which of the following is not true? Okay, both Hg2 plus and Hg22 plus ions show the die and the ionization potential of 12 group metals are fairly greater than those of the coinage metals, yet more reactive than the later. Ionization potential of mercury is smaller than that of cadmium. Zinc, cadmium, and mercury exhibit positive oxidation potential. Okay. So which of the following statement is are true? Okay, so it is a multiple choice correct. Can you guess any option? Okay, so I have got like A, B, C, and D. Another answer. Okay, so we'll check the answer. So both Hg2 plus, Hg2 2 plus ion shows divalency. Is it true? Both shows divalency. So I have like Hg2 2 plus, right? So it will be Hg plus bond Hg plus. It shows divalency and Hg2 plus also shows divalency. So option A is right. The ionization potential of 12 group metals are fairly greater than those. What are coinage metal? What are coinage metal? Copper,
Zinc.
silver, gold. These are coinage metals, group 11. Okay, so ionization potential of group 2 is greater than those of coinage metal. It is like more reactive than the later. Yes, why it is like more reactive? So when you take like group 12, X mercury, okay, so they have the positive oxidation potential. Oxidation potential. Okay, so since it has the positive oxidation potential and the coinage metals have negative oxidation potential. So since it has the positive oxidation potential, they are more reactive. And ionization potential of mercury is smaller than that of cadmium. Mercury and cadmium. So cadmium has the smaller and mercury have the higher ionization potential. This is due to the weak shielding of f orbitals. So option C is going to be wrong. Zinc, cadmium, and mercury exhibit positive oxidation potential. Just now I told you, like mercury alone has the negative potential, negative oxidation potential. Okay, so why? Because it is experiencing the weak shielding of f orbital. So therefore, like zinc and cadmium are positive, this has negative. So this is also wrong. So the correct answers are like A N. Okay, clear with this question?
Yes, ma'am.
Okay. So the next question is, which of the following statement is are not correct? You have to choose the incorrect statement about the corrosive sublimate. Okay, so what happens, like what are the statements given? It's a solution get with Ki not in excess, and its aqueous solution white with excess of SnCl4 forms with SnCl2 solution, and it decomposes heating G2Cl2 and Cl2. Now you must know, like, what is corrosive sublimate? What is corrosive sublimate? What is corrosive sublimate? HgCl2 is corrosive sublimate. Okay. So now when HgCl2 reacts with this 2 times and will be getting HgI2. So now, okay, so option A is correct. That is correct statement. And second one is its aqueous solution gives white precipitate with excess of SnCl4. Actually, with excess of SnCl4, there will be no reaction. So it is incorrect. It forms gray precipitate with excess of SnCl2 solution. Okay. So when HgCl2 reacts with SnCl2, you'll be getting like Hg2Cl2 plus SnCl2. Okay. Now again, this will get decomposed to form Hg. So Hg, we know that it is gray in color. Okay, it forms gray precipitate. So therefore, it is also like correct answer. It is correct. It is not incorrect. It is correct. Next is it decomposes on heating to get HgCl and Cl. Like HgCl2 is thermally stable. It won't decompose. Thermally stable. It won't decompose. So therefore, the incorrect are B and B. Okay, clear? Moving
Yes,
to the next question, like what is the yes? Is there any?
no, ma'am. Clear.
Okay. What is the oxidation state of chromium in butterfly structure? What is the oxidation state of butterfly structure? We this
Yes.
is the structure. What is this? CrO5. Yes. So we know that we have to already. So this is butterfly structure. So the oxidation state is like pluses. Okay. So double bond minus 1 minus 1. So that was oxidation status plus 6 after the going to be 6. And out of the following, how many oxides are acidic in nature? This is like important to know, right? How many oxides are acidic in nature? Can you tell me, like, which oxide will be acidic? The one which is having higher oxidation state or the one which is having like lower oxidation state?
Repeat, ma'am, please.
Will be more acidic. One has high oxidation state or low oxidation state, which is acidic and which is basic.
Ma'am, high oxidation number, acidic, high.
Acidic and low oxidation number is basic. Okay. So now you have to find out like how many oxides are acidic in nature. How many acidic in nature? Like M into O7, what is the oxidation state over here? Plus 7, which is high. It is going to be like acidic. And when you take like the oxidation which is high acidic. M in O2, the oxidation state is plus 4. It is acidic. Like M into O3, the oxidation state is going to be, and here it is like plus. Okay. So therefore, what is the total number of acidic OH over this? Yes. And like you can answer this question. What is the value of X in the instance gas? Rx pH3 pH, which is used as an homeostatic origination of alkene. What is the X? What is Wilkinson's catalyst? What is this? Triphenyl phosphate. Phosphine. Okay. It is so it stands for CH3 P 3 times. What is the coordination complex? What is the coordination number in this complex?
Four.
Okay, 4. So therefore, the answer is going to be X value. Fine. So, how many of the transition metals are called platinum metals? How many of the transition metals are called like platinum metals? Platinum metals. So what are platinum metals? So this is 5. Okay. 40 series and ICP group 8, 9, and 10 are platinum metals. That is like ruthenium, rhodium, palladium, osmium, erbium, platinum. All these together are said to be as platinum metal. The answer is going to be like 6. Okay. So the last question, it is a paragraph type question. Okay. After insoluble solid A, it turns yellow on heating and becomes white again on cool. Okay. So what is you have to like do A? What is A? When it turns yellow on heating and becomes white again on cooling, HCl, it forms a clear solution B. So A HCl gives B. When A is treated with NaOH, it also gives a clear solution C. When H2S is bubbled through the B, okay, there is no change observed. No change observed. But when H2S is bubbled through C, you'll get a precipitate B. Okay. So now what would be the compound A? You can choose like from the 4 options: zinc oxide, manganese oxide, lead oxide, and cadmium oxide. You can work out using these four. Okay, I got like one answer is B. Taking oxide, okay. So zinc oxide on heating, what happens? Like it will undergo the zinc oxide on heating, what happens? Will it give color like on heating? What effect will it undergo? It will undergo the metal deficiency defect. Metal deficiency defect. Yes, we have studied it in the, if you have gone through the solid state, you could have gone through this. Okay. Metal deficiency defect. Okay. So in metal deficiency defect, what happens is like zinc oxide is, okay, zinc oxide will be there. And when you heat it, okay, so this one will produce the vapor. Okay, zinc 2 plus vapor will be there. Now, one of the zinc will form into two electrons are there. Okay, now you have like zinc and oxygen inside the crystal lattice. Okay, so now zinc 2 plus will give out like 2 electrons. It will out zinc will give out zinc 2 plus and 2 electrons will come out. Okay. Now what happens like one of the oxygen will move and it will combine with zinc to form Zn4. It will form Zn4. Okay. So now so it should be like metal X, not metal deficiency, metal excess. Now oxygen like moves out, right? So of oxygen molecules in the crystal lattice will decrease. It means that the metal will be in excess. Okay, so that is said to be as the metal excess defect. So when you heat light to this now what is like this oxygen will be vacant. So the electron is there, right? So that electron will capture the space, the vacant thing. Now there is like movement of electron. If there is like movement of electron, we know that it will give color. So that's why when you think it gives yellow color. Okay, and on cooling, it becomes like white and green. So it's just HCl. So when ZNO is reacted with HCl, okay, what you'll be getting? Like you'll be getting zinc chloride and water. Yes, zinc chloride. So now this is if I'm assuming this as B. Okay. Now do ZnCl2 react with H2S. Do ZnCl2 react with H2S. Do ZnCl2 react with H2S. Will it react with like H2S? Now I have like +2 oxidation state. This H2S is the reducing agent. It is a reducing agent. So what it will do, it will try to oxidize zinc. Will zinc get oxidized? Will zinc get oxidized over here? Sorry, it is a reducing agent. It will reduce, right? So will zinc get reduced from oxidation state? No, here the plus two oxidation state is going to be like more stable. Okay, so there will be no change at all. Therefore, the option A. Now, moving to second one, what would be the compound B? So we know that we have done already. Zinc oxide react with to form ZnCl2 plus H2O. So the compound B is going to be like ZnCl2. Now, what is the change of color from green to purple is due to? The change of color from green to purple is due to manganese +6 to +7 or +6 to +4 or +4 to +4 to +6. Green to purple. Green to purple. So which is purple in color? Like we know MnO4 is purple in color. Yes. What is the oxidation status? +7. So either option D or option C should be the right answer. When it option Mn +6 to MnO4, the oxidation state is +6. So when it reacts water in presence of carbon, like MnO4, MnO2, O2, KHCO3. Okay. So now what color you got? Like +7 and what is the color of MnO? Okay. So therefore, option A is the right. Got it, everyone? Yes. Fine. So that's it for today. Okay, I'll share the PDF in the group. You can go through it. And for tomorrow, right, I'll just tell you the chapter so you can go through the chapter and come back. Yes. Like, are these questions useful to you? Okay, so tomorrow's thing is like coordination compounds. So you can go through coordination compounds and come back tomorrow, okay? And Friday you'll be writing the mock test and the paper discussion will be held on Sunday, okay? Okay, so go through coordination compounds and come back. And is this source of episode? Yes, fine, Aditya. Okay, I'll give you like few important reactions. Okay, fine. Okay, guys, thank you. I'll meet you tomorrow. Bye bye.